Perfecto. Bueno, muy buenos días. Aquí va.
Good morning. We're going to start this workshop. I hope you enjoy it. I know it's very early, so I'm going to try to wake you up with something that's interesting. I don't know if you know about the cloud world. There's cyber response. We've got some forensics here. You can do all sorts of things. You're going to like this because it's called Incidents in the Cloud, or FAAS, which is a term that was coined many years ago. Forensic service. And we're going to look at the whole process and look at it from a technical viewpoint. I hope you enjoy it. I should like to thank INCIBE for inviting me here. This is what I do. This is a little bit about me. I work in Prosegur, and I'm in charge of the digital forensic service. There is my education, the certification that I've got, and what I do outside my job. I'm a lecturer, I'm a cyber volunteer for the INCIBE, and I'm a speaker. And on the bottom you can see how I'm was when I was younger. Let's start with the table of contents. We're going to mix things. Here we're going to talk about the general concepts today, but they're going to be all mixed up. FAAS, which is a service offered to different companies who offer services to other customers in the cloud. We're talking about forensic issues, and you have to have the appropriate team for everything that you need to do in the cloud, and I'll explain that a little bit later on. I also need to make a disclaimer, because every time we're going to do concept trials or some kind of an ethical hack, we have to tell people. Here we're going to talk about three providers that are the most important: Google, Azure from Microsoft, and Amazon Web Server. These are the three main ones, and we're going to be concentrating on them. In my talk, I'm going to be having it'll be a basic, average, medium-level talk for anybody that's in this room. I think you'll find it useful. So, an introduction. Let's look at the whole of the model from the left to the right. On premises is what a forensic offers. Typically, you've got all the machines that you manage, and in this kind of model, you can have SaaS and PaaS and ES. So you free up control of hardware. So you can have a forensic, but there are other conditioning factors. Then you can see all the different controls that you have to have. What you manage and what your main supplier manages, and this is very important. I like this slide because it shows how systems used to operate before 2005 in IoT networks. Everything was centralized. How it looks today, where things can be controlled from the cloud, and there you offer different services. And what we expect to happen from 2025 and beyond. This is very interesting because everything is going to be decentralized. It's going to be distributed. There'll be a communication between all the different devices and the cloud, and it'll all be automated. And it supposedly is going to be distributed via blockchain. I think that's very ambitious and also very interesting. And that's why it's necessary to have this kind of services like a FAAS. because you need to have some kind of control if an incident happens. You need to have sufficient skills to know what has happened. Let's get to the point. I remember at a talk once, at a Microsoft talk, somebody said, oh, there was no doubt about the level of safety in the cloud. I thought, well, hang on a minute. Maybe that's not true, because at the end of the day, the cloud is managed by people. We all make mistakes. And at an infrastructure level, there are mistakes every day. There are errors every day. A couple of years ago, started looking into the cloud issue with different suppliers. And I looked into security. And of course, it's not 100% safe. So let's see what we can do and what sort of forensic services we can offer. There are many incidents that can ruin a small company or a large company. We've seen news about PlayStations. I think it was a few months ago, how that was harmed. And that could happen in our company. So let's imagine you've got an instance. Your computers aren't well maintained. They've not been updated. They've got a bad setup, and you're exposed to internet. This is a typical example of what happened. And you of course, can be very vulnerable. You might have bad developments and bad implementation. And there may be an error. We're all human. So people may upload something like a Cowler into the cloud, and our service provider then cuts the service to us. And that's just because of bad implementation. This is going to have an effect, of course, on the company. And there's also malpractice of users. If your users aren't properly trained, they may accidentally let malware in. And then passwords may be very, very exposed. It's far more than people think, because you've got developers that are using the cloud. They could hack into passwords or access code. So you need to be very careful with this, because there are people specifically who try to do that. So we need to be very careful. And then a combined attack, and that is using the cloud to attack a third party. We've seen that as well. That can happen. We saw it in PlayStation and in more cases, but people try to cover that up, but it actually does happen. Okay, what sort of challenges do we face when we offer this kind of service? Firstly, we need to have a good relationship with our supplier, our customer, and ongoing communication. That's going to make everything a lot easier. We need to be very agile when asking for control over all the elements that are in the cloud. And to be able to work, we of course need permits. And you can't have to ask for the permits when the incident happens. You need them before. What about the characteristics as well? Because everybody has different concepts. You can make a simile, for example, between Amazon and Google. And they develop characteristics that may be similar, but actually technically have small differences. And you need to know all the different characteristics, what sort of security levels they have. So we need to be very much up to date of all changes and everything that's progressing, because that can help us. Also, legally, the jurisdiction, it's very important to know what you can do and what you can't do. You may have your data center in one place, your server in another place. So you really need to carry out yourself some kind of audit of what you can do and what you can't. And you need to be honest. If you end up going to court, you need to be very careful with your integrity and how you look after the chain. A forensic service, you need to have things that are traceable as well. But here, normally you're just firefighting. So you need to always, for example, record on video all the different processes so that if something goes wrong and we have to go to court, we need to be able to provide evidence of what we've been doing. Preparation. How do you get ready for this? I think there are two service models. One, which is being a firefighter. If something's happened, nobody knows what's going on. You're called and you have to go and put the fire out. That's what a firefighter does. That's the situation that I really don't like. I prefer to have everything prepared. I prefer to be monitoring everything. But sometimes you have to go and put out a fire. And that's is costly and requires time, especially if you go to a place where you have no idea of the architecture. You need a very rapid response. You need a rapid response team, and you really need to know what you're doing. Keep a cool head, know what to do, where to stop. They're critical decisions that you're taking at critical moments in time. And so it's very important to know about architecture. I've already spoken about legal side of things, and that's also important. So if you're being a firefighter, of course, you need to be able to contact with a delegate to say, okay, we've got services in several countries that we're going to offer, which includes, of course, monitoring service, then which you've got everything agreed upon with a client, a series of service level agreements. So you've got to go to the critical points. What do we forensics really like? We like logins, we like system administrators. So we need to try to create everything that we want, as if it was like a funnel going into a machine, so that you can get everything possible and create everything that you need. And also the relationship with other endpoints. This is, of course, important. If we've got a cybersecurity incident and the patient, as it were, is ill, we need to isolate that case and see what it affects. So we're going to need a profile, an auditor's profile, and the necessary permits to work as a forensics. And in the end, we need a series of resources which we can have in the customer's premises or on our premises. Because you can be offering a forensic service to their cloud directly, or you could actually go to their cloud and bring down everything that they have. That takes a little longer. And here you can see how the service is set up. It's a very simple diagram. If there's an incident, you have to sit down with the customer, write down the basic data. It's very important to have a contact person. You need to know if something happens, who you've got to ring, who's got the passwords, who knows about this, because this is a continuous, ongoing service that you need to be able to offer 24 hours a day. You need to know about the infrastructure. You need to sit down sometimes with the client for a week and to see what they've got and compare with what the client says with what you can see. And that always needs to be connected and kept up to date. So there's data collection there. And then we wait until something happens. It may well be that the customer calls us or we realize that something's happened, but these are the three things that you do. You need to detect, isolate, and contain. This is really, really important when an incident happens. That's what we offer our customers. First of all, you know something has happened. You isolate that incident and you contain it so that the service can get back to normality. Then we analyze anything, and if there's any discordance between the original data that we collected, we see, oh, you didn't say that this had been updated. So at the end of the day, what you're offering is a continuous improvement service. Now let's look at a demo. Concepts are very important before we start looking at a demo. And depending upon the customer and the infrastructure the customer has, you can do some things and others not. We can have some logs and others not, depending upon the supplier. So decisions need to be taken, and there are always upsides and downsides to everything that we do. So let's make a machine for somebody that's just started out in this world. And we can have, in this case, a SIFT virtual machine or a SANS. It's easy to set up. We'll do it in its most recent version, which was updated yesterday. And then we'll put it live, and then we'll see how, if at a given moment in time, a client has an incident, they call us. And we set up a lab in the cloud, and then what we'll do is get the evidence and then connect the two. The good thing about the cloud is you can do things remotely. And then we'll see another couple of demos, which will be at our forensic site. We'll get all the data, we'll get evidence capturing with all the guarantees, and then we'll work on that. Okay, those are the demos that we're going to see. This is the first one. We're creating the instance. Here, I don't know if you can see, we're creating it from zero. In this demo, by the way, we've done this all free of charge with the instructions that you're given. You're given a series of credits to do it free of charge. And why do we do that? Because we want people to see how important it is. Of course, your machine normally won't be sufficient. You want more processing power. And the machine that we have here is quite basic. So what we're going to do, of all of the options that are here, this one, we'll choose the free option. It's got a giga of RAM memory. There's a whole suite of things that you can choose from, up to 16 RAM. So, of course, it depends on the needs. So let's move on now. Of all the different options that are there, we're choosing this one. Here we can customize it a little bit. Here's everything that you've got to choose. By the way, each one of these elements has a cost attached to it. We choose this one. Depending upon the geographical area where we happen to be located, we'll leave this just on default mode. This is the network. You can also customize a series of details, but for the moment, let's just leave it as it is. There's the machine's capacity. We've got up to 30, so we'll just write here 28. The type of drive that we can, let's have the SSD. It's not encrypted. And off we go. Here you can see a series of tags. This is just to get organized. We've got several machines. We need to identify them. Let's go to create. And here we can set up a security group. There are all different security groups that you can choose from. We've already set one up, but I wanted you to see it. Here you can see we've set one up. And so let's choose this one. It's a very basic one. It says H, RDP. There you go. We've customized it. This is the one. And we launch it. There's not much now to do to finish the process. And there you've got everything that we've selected. You can see it all. Here we choose equip. What we want to do is to create a virtual machine. So what we're going to do is give it forensic functionality. There we are. It's been created, the machine now. Takes a while. I ought to say that we shortened the whole process just so that you can see it. There's our public IP. Let's connect, and now customize. This takes a while, this process. It's there you can see the machine's tag, unlike others. This account I've actually created specifically for this. Where in the description part you can see everything that you have. You can see what the CPU, how the CPU is, and everything else. There you can see as well how it's updated. Sometimes it takes a while to update. There we can see the region, which is always very important as well. And there's the code. You can see it all. I'm going to stop it there. What we're going to do is to set up the environment now with a series of commands. The best thing is to have it visually. We can see real-time reports, timelines. So that's the mode we're going to ask for it, so that we ask for it to be an RDP with a basic normal desktop. And you open it. And secondly, what we're going to do is install it. There's a series of commands. We're going to go step by step. It takes a while, but it's an easy process. Here you can see on the last line but one, we've got version 41.1 of 2017. There are more update ones, but this one is fine for the moment because the others have been problematic. So it's a basic machine. It's just a basic computer. It's got a core. Let's carry on. With all this information, and I'll put it in my GitHub. There you can see user and password. There we've created the instance. And what we're going to do for the forensic work, now we've got the machine. What we want to do is to put all the evidences there. So we're going to create a disk, and we'll match it. So we can see what we've got now. This is the incident. And you can see the machine. I've got my profile here. It's not the best profile, but it's only a demo. Let's move on. This is what we saw earlier, the same as we saw via SSH. And now, let's look at volumes. There's a snapshot of the machine, what it's looking like. You can have people working on these different snapshots. So we've got our hard drive. We've asked it to investigate what's going on. There we can see what's going on. We've got the authority. And then we wait. It takes a while. And we'll have it in our machine. We carry on. It's located in our machine. So we then move on and work with it. So it's easy, really. Our machine, our forensic machine in the crowd with our evidences, and we can work with it as if we were just a normal forensic. That's as far as we're going with that demo. Okay, let's now do another kind of a demo. We've got a machine in the cloud, an Amazon machine in the cloud. Let's now do a demo of a case that we did with a machine. In this case, it's an Azure that we're using. And we've got it's a machine for a business environment. So we were called. They said, we've got some very suspicious logins, and it looks like there's been some kind of intrusion. So we have to somehow access it and see the characteristics of the machine, and then how we can extract from the RAM memory and look at a series of artifacts, which are key files that will give us an idea of what's happening. In the end, what we're going to do is add a hard disk to it with a series of tools. This is the instance that we have. This is our virtual machine. This is what the diagram, the setup looks like. It's very, very basic, seriously basic. We've got a subnet and an interface, public IP. At the bottom, you can see the security group and the virtual machine. It's easy. And that's our environment. We can see it at the bottom. There's the server. It's got the firewalls on. It's fairly updated. It would seem that everything by default is okay. Here, I'm going to see if I can stop this. So what we do is, okay, once again, we've got this machine with its hard drive and another series of hard drives. What we do is we put hours there with our tools. We'll talk about the tools a little bit more in detail. And what we're going to do is work on the information in that hard drive. What we do is isolate the information and we take it to our machine. And this is what we're going to use here. For those of you that work on incident response and forensics. This is what we're doing. It's a live response collection. What it is, it's a link. I don't like it for Mac and Linux, but it's good for Windows because it's got a series of tools, different versions, they're free. And what it can do is it can edit, you can edit them. It's got scripts that you can edit as you want them. And that's what I'm interested in, because each case may be different. So you have to extract them as you want to. And with this tool, you can do it with the artifacts, with RAM memory, and with disks. So we've got the RAM, artifacts, and off we go.
Vale, pues ya hemos entrado en la máquina.
So we get into the machine. The unit has been configured. We have allocated a letter, and it's there. We identify it as new volume, unit E. Here, in this file, we have the skips. With all the skips there, we have configured the tools. And these two directories, these two files are like the same. You can get system data and this nomenclature. When we'll execute again the pack, it will require another file, and then we will dump there the whole of the content. We'll execute the bat, and it starts with RAM memory, which is quite longish. Here we get into the file and we see how it is generated. First we have the memory. RAM memory is there, and the image disks. We can't do anything against that. And here the process, 5%, 28. It takes time, depending on your memory, the processing power. Let's see all the tools. 32 and 64 versions for each one. A series of tools. And here we are using this one, RAM capture. It's very basic for forensics. In this file, we have all the information. Now it's being generated. This is not a good practice. While you do the extraction, it's generating the files up, but this is a demo, so it's okay. The process is continuing. The back, each one of the files is being fed. These are the logs and the records that we're going to see in our lab. We have last activity view. We will show the last processes that were made in this machine. It's Excel format, almost. It's HTML format, but you can convert it into Excel format. So here we will analyze this data in detail, but this is a preview. Let's continue with the process. It continues to generate files, giving a lot of content. Let's do it. The message is okay, be patient, it says. It's quite a long process, especially with big machines.
Vale. Aquí seguimos. Vamos a ver otra serie de carpetas.
Let's continue with other files with all the information that's being generated. Here, there were errors. We have to analyze why. What are the records that haven't been generated there? Well, let's do the extraction. Maybe later on we don't need to go back. We need to analyze each error. We'll have a log with all the processing options, and we will see what has happened. Here the other files that are important. In the records, we'll have a lot of information. Then we'll have to analyze it in detail. There are many tools that include all the detailed information. We have to see if it's complete or not. Hosts information.
Bueno, más información.
More information in the network, the seaport. The client sends a series of logs, and this machine is published in the internet. So at the level of connection, it's very important to see all the events that happened. Let's browse the files. The auto-runs are important too. When there's an attack and you want to have persistence, it's very common to go to that auto-run section.
Se sigue ejecutando, ya estamos terminando.
This is the end, and let's see the whole process. There's a detail of all the processes that have been followed. File creation for good integrity. We see what we've done. So we have the forensics hat. We've supervised what's happened. The hashes of all that is obtained is saved. We have a series of important hashes. And then we have to go to trial. We need to explain this. This is the content. It's traceable, the versions, the programs that have been used, the licenses of the tool, and everything is logged. Internal ITAs, and we are near the end. Until it's completed.
Vale, y al final pues nos...
So this is the end compression of the file, and we stop here. Once we're doing this option, we can use other. They're not investigative applications. They're just environments for investigation. If we're a team, we can do it together in parallel. Here we have Windows PowerShell. We connect to the clip CLA, and we can do several things at the same time. If we know that there's an incident, at the same time we do the acquisition of the incidents, we can create an investigative environment, and we see logs appearing, and we'll see what we do with that. We need to have the client's authorization. It's important to ask for authorization. We have this option. We can do a lot with this. It's very powerful. And we have others. That is, this is offered by Azure. It has to be configured upstream. You can't just do it there at any time. It has to be working before Azure Analytics will do it. On the left, you can see it, a series of consultations that we can that are pre-configured, and this is adapted to a client, to this instance. Here, it's in Spanish. You pick the consultation, you edit it. Ideally, it's been pre-configured for your client. You have already your instances, and then you only need to execute. And it gives you all the information, and the extraction is done at the same time. We can do several things. We have a team, and if we have a team, much better. Let's continue.
Vale, esto es una de las...
We've done the extraction. We've got the compressed file, and we brought it to the investigative forensics environment. Each provider has its own features. In Azure, we have a Windows server. It has its own file. And so in our report, we need to clarify that. It has its own characteristics and specificities. So in the analysis that we've done, we have the seaport. This is just about investigating, inquiring. We have a lot of logs, and at the end we can't find an application. The one that you've seen there at the bottom, there's something that's strange. Let's do an investigation. But this is quite striking. What about this application? What are the programmed tasks? Maybe the program is there, it's embedded. This is not in Azure by default, so this is strange. And then we see other things in the last activity views, and there's something that is not in the right place. So we can have leads, and it's a whole investigation, and it gathers a lot of information. We are getting to the end of this part. Here we have information available, and then we can inform about this event. So you have this information and you have no clue. So you have to mine the process and go back to the initial process. You need to have a vision and investigate what this process does. This application is a malware, according to certain people. But if you go to the source code and to the GitHub, we realize it's a control and administration in Windows. So there's a link where you see the tool, how it is created, how it's compiled, and how you can adapt it to your needs with lots of options. That was in the machine. That was the incident. So we analyzed it because we have the RAM memory. We didn't see anything. We've seen the artifacts. We have the RAM memory that is key in this case. So we use volatility. We do an analysis. This is just a summary. So we have the profile. We have of the RAM memory. We've taken this instance that was connected to a specific port, to a specific IP. There was an established connection, and it was controlling the system. So it's important to know volatility, to use volatility for these cases. All the data that were in the artifact station do correspond to what appears in the RAM memory at this precise moment.
Vale, ya con esto hemos terminado.
And we've finished this part. Now we get to go to the last demo. So extraction of a hard drive, partition of a hard drive, or various elements in this Google Cloud. We're going to use a configured program. We are going to connect. We'll extract partitions of this hard drive in our forensic environment. We can go to a bucket in the storage in Google. We can do it also. But here we see the Google Cloud platform. We have our platform here. Let's see what happens. What I do at the beginning, with all the instances that exist, I choose the one I selected, version 7, which is enterprise, and here you have the features, the cost of this environment. It doesn't matter because I had several dollars to test, so I believe in it. Location is important. This is our machine. It's working. CPUs, it's a very basic machine. the drives of this machine that are created by defect, 10 gigas. We have no capture, no snapshot or whatsoever. And this is the ECLI. Let's do a capture, a snapshot of what's happening about this precise instance. We can do it visually, but if we have a fire, the best is to do it through the command line, the console. Well, it takes some time. Let's analyze the sentence. You have EG Cloud. You type the project. You identify the instance. And what we're going to see now is the fact that we're going to create a snapshot that will be named precisely like I said. It takes some time. We have shortened the time. We are using a basic version. And at the end of the day, cloud computation takes its time. Here, there's our hard drive. Here in captures, it is not there for the moment. It's still processing. When it finishes, we'll see that in the drive file. Let's do an image, a snapshot. Let's see the difference with an image.
Vale, aquí ya lo hemos pasado un poquito más para...
So we've pushed it. It hasn't finished yet. Now it's there. Finished. It's done. It doesn't refresh properly, but anyway, let's browse. And here we see our snapshot ready. It's here. I don't only want to do a snapshot. I do anything that it's required. I've done a snapshot because I can't stop the environment. I have to do it very quickly. And now I have the possibility to create an image. For this purpose, I have to stop the machine. I'm doing it now. And I launch another command for the creation of new images. We've done it more rapidly here. I have the created image for CyberCamp. I run the process in a rapid mode and I have our image. The information is quite scarce. In the command process, it's richer. And here I could make an instance. There's another post that is associated, different environments, cost, but we're not going to do it now. Here, the message is created, done. All the details are going to be sent to my GitHub. The instance, it can run again because we already have the image, so it can continue its own operation. And these are different elements. Each provider, this is a storage, a file with the image that I created through the command line or the web. I can send it. Here, with the CCH, it's launched from the web. You don't need to have a client installed. You can do it, but you have the option. You enter from there, and you see what's in the instance. We can do a DV, and we can send it, we can compress it. We can do a lot of things with this from the instance itself. We have a DD, we have our CLI, and then we can send it to our PC or to a bucket. Let's see if I stop it with this instruction. This row. I wanted to include in my D, in Drive, in my machine, in the file called evidence. It could go to a bucket. Of course, we only need to change the instruction. In our G Cloud, the command is SCP. So we run it. Depending on the weight, on the size, it says it's okay, it's clear. The time that it takes, it's quite longish. So I accelerate the process. And that's it. And we can apply other commands for integrity. I said it's important. From there, we do an MD5, 56, whatever. It's quite powerful. And here, this is from a colleague, Tony de la Fuente. This slide was taken from his presentation, and it's very interesting indeed. Here we have a series of tasks that he runs when there's an incident, a security incident, and something that you can manage, for instance, the case. Here we see a process that is quite nice to see of all the tasks that are carried out. But you need time for this. At the end, when there are instances that are compromised, you see the process, if it's dead, if it's alive, a series of applications. Then you have to read it with time. All the forensic stations that can be used, the tools, we've seen some of them, a whole process that at the end of the day has to be automated, and you can create a case with the provider. So the more automated it is, the better, especially in the main levels at the beginning. All this part has to be automated. Then there's a point when we have to do manual work, but in these cases, time is money. This is the last part, my conclusions. We have to make differences. From the point of view of the client that gives service, these points are fundamental. We need to create these environments from the point of view of security, of IT security, because normally if there is a store, it's critical for the store. All the client and customer service are critical, so you have to see it from the point of view of security. As for alerts, that's fundamental. People managing these environments have to be careful about alerts, that you need to have a refined system of alerts and alarms. In all your developments, you need to have a strong auditing behind it. Auditing all the systems and all the people who work, and for all developments, you need control over that. And from the point of view of what we give, people giving service, we need to have the permissions and the authorizations. That we have an action plan for each customer. So it's our responsibility to ask for those permissions. Otherwise, we can't offer our service. It's important also to have a resource pool. We can have free software or proprietary software, but you don't need to marry with anyone in particular. Choose whatever you like. In Prosegur, we have the seller right for mobile devices because it's a rapid service. We can do a lot of things, and it's a proprietary service, but we can use free software. So there's just not a single choice. Choose whatever you like, and we need a continuous training. You have to be aware of all new elements in security. You have to be 100% updated. Many providers, many features and the evolution level and speed of each provider is very, very high. So we have to be updated. Thank you very much. Here you'll see my contact in the GitHub. You'll see the code, the presentation, videos, everything is there. You can contact me through the social media. I'll be here for the whole day, and I hope you've appreciated. Thank you.
Si alguien quiere hacer alguna pregunta.
If you have any questions, but I'll be here for the whole weekend, so I'll be here for you. You can stop me, we'll have a coffee, we'll drink coffee, and we can discuss.